Hello friends, in this video I'd like to solve the following problem from the Balkan Mathematical Olympiad 2023, problem number 1. We want to find all functions f from the set of real numbers into itself such that x times f of x plus f of y equals y minus x times f of x for all real numbers x and y. So here are my hints for this problem. First, is function which is constantly 0 a solution? You should verify it easily. And then consider two cases. First case, when f of x is constantly 0 for all real number x, show that our function itself must be constantly 0. And if it's not the case, so if f of some argument is not 0, show that in this case our function must be injective. And then do the following. First, set x to be equal 0 to find f of 0, and then finally set x to be equal y, but not 0, and use injectivity to find f of x. And finally, what about f of 0? Does the formula hold in this case? We should verify it. And also recall this useful fact that if we have the composition of two functions, h composed with g, and if it is injective, then the inner function g must be injective as well. So give this problem a try and I will see you in just a minute. Okay, so here is my solution. Maybe let's write first that function, if f is constantly 0, then f satisfies our condition, which I mark asterisk. Okay, no problem there. Why is that? Because here we have 0 and here we have 0 as well. No problem. Now, suppose now that f of x is 0 for every real number x. Then let's set then our condition asterisk becomes the following: x times f of x plus f of y equals just 0, because here we have f of x and that's 0 by our supposition. Now let's set something. So set x to be non-zero, and for example let y be equal, for example, f of 0. Then we have the following: x times f of x plus f of 0 equals 0, but what is f of 0? Well, f of 0 is 0. And we can safely divide by x because x is not 0. So we have f of x equals 0 for every non-zero number x. And what about 0? Well, notice that in particular, for example, 0 is f of 1, so f of 0 is f of 1, and f of 1 is 0. So, in other words, for every real number x, f of x is 0. No new solution was found in this case. Finally, suppose now that f of x0 is not 0 for some real number x0. Then let's set x to be equal x of x0 in our condition asterisk. We have the following: x0 f of x0 minus f of y, or rather plus f of y, equals y minus x0 f of x0. And let's look on the right hand side. Let's treat it as a function of y. Well, this is an affine function which is not constantly 0 because this coefficient is not 0. So function which maps y to y minus x0 f of x0, well, it's bijective, but I will only need injectivity. So it's injective. It's injective, so the left-hand side must be injective as well. So function which maps y to x0 f of x0 plus f of y is injective as well. Is injective as well. But this function is really a composition of two functions. The inner function is x0 plus f of y. So function which maps y to x0 plus f of y is injective as well. It's injective as well, which of course means that f itself must be injective. Let's recall that, because we will use it later. Very well. Now let's set something else. Let's now set x to be 0. X to be 0 in our functional equation asterisk. Then we have the following. This time the entire left-hand side is 0 because we have x times f of x plus f of y, and on the right-hand side we have y times f of 0. And remember that that should be true for every real number y. The only possibility for this to be true is that f of 0 must be 0. It's the only possibility. So f of 0 is 0. Let's also remember that because we'll use it in a minute. Finally, let's set x to be equal y and let these numbers be not 0 in our condition asterisk. What then? Then we have the following. X times f of x plus f of y, and this time the right hand side vanishes, because if x equals y, let's take a look. If x equals y, this is 0. So the entire right hand side disappears with 0. Since x is not 0, we can divide by x. And also x equals y, so let's write x. But what is f of 0? Well, f of 0 is... What is f of 0? F of 0 is f of 0, as we have established. And also maybe let's write this also in. Very well. So now we know that f of something equals f of something else by injectivity. By injectivity of our function, we know that x plus f of x equals f of 0, or f of x equals f of 0 minus x for every non-zero number x. But what about 0? Well, if x equals 0, this is also true. So notice that f of 0 equals f of 0 minus 0. So for every real number x, f of x equals, let's say, b minus x, where b is a constant. So we are almost done. Now what we have to do is to do verification. So we need to verify that every function of this form satisfies our functional equation. So let's just compare the left-hand side and the right-hand side. On the left-hand side, we have x, f of x plus f of y. So it's x, f of x plus f of y. So it's b minus x plus b minus y, if I'm not mistaken. So it's x times y minus x. And on the right-hand side, we have y minus x, f of x. So it's y minus x. What is f of x? Well, it's b minus x. So once again, it is exactly the same. So every function of this form satisfies our equation. And remember also, at the very beginning, we have verified that function which is constantly 0 is also a solution. So all in all, the solutions are the following: f of x equals 0, or f of x equals b minus x, where b is a constant. b is really any real number whatsoever. And that closes our problem. We have exactly 2 families of solutions. So yes, thank you very much for watching. I hope that you were entertained by my talking, and I will see you next time. Goodbye.